This week we go into geoprocessing, which is really the icing on the cake for geospatial analysis. So these processes will be used for vector data. When we get into raster data, there's a different type of processing, raster analysis, because the raster data will coincide exactly square for square. So you could have 10 raster layers, and every grid in a raster will be directly above the grid below it. So I could stack soil type, I could stack zoning, I could stack precipitation and elevation all in one analysis, and for any area find out what the combined values would be for that raster layer. But vector layer is really based on geometry that doesn't coincide. So my polygons for my land areas, my land zoning types, are going to be a little different shape and size than my polygons for wetland areas. So these processes work for those types of data. So there's overlays that combine attributes from features, and then there's overlays that just kind of do a truncating or clipping. So we worked with intersect this week or the week before when you were kind of comparing that to spatial joins. So there's two overlays that combine information, a union and an intersect. And then there are two overlays in this chapter that do not, the clip and the erase. So we'll take a look at both of those. The union and the intersect overlay you can get in the geoprocessing tools or the analysis tools in ArcMap. So a union is taking two different features and combining them into one new feature class, and it combines all of the geometry, so the areas that overlap and the areas that don't overlap. So I take this equilateral triangle and it's overlapping that rectangle, and what I get out is the shape to my right, which I'm sure has a geometry name, but that was I'm not spending time looking that up. The interesting thing is that this part of the triangle, of the rectangle, will end up with only the attributes from the rectangle, and this part of the new feature will have only the attributes of the triangle, but the right triangle in the middle will have the attributes of both features because it covers both features. The intersect keeps only the common areas, and again, that area, that new right triangle would have all of the areas, features that are common to both feature classes. The clip and erase are extraction overlays. So the clip takes the attributes of the feature being clipped and ignores the attributes of the shape. And so one way to think about this is the cookie dough and the cookie cutter. So the rectangle is the cookie dough, the circle is the cookie cutter, and the output has the shape of the cookie cutter, but the attributes of the cookie dough or the feature underneath it. Now, all four of these features automatically create a new feature class. And so again, knowing what you call them, knowing where you sent them is pretty critical. The erase is kind of the opposite. It keeps the attributes of the area outside the cookie cutter. So we've talked in the last chapter, you talked a little bit about, or you wrote a little bit about the difference between select by location and select and the intersect geoprocessing tool. So I want you to be able to really discuss when you would use these different functions or tools, union, intersect, clip, erase, select by location, select by attribute. What would be the benefits? What would you get out of that? I want to just back up a little bit, talk about shape files. So a shape file is an older geometry format. It's called a topological file, in that it doesn't keep the coincidental lines intact. So I can move Oregon away from Idaho if I want in a shape file, so those lines aren't fixed together. Shape files, when you look at them in ArcMap, in the Arc catalog, this is what you see, kind of the green symbol instead of the gray for the feature classes. But if you looked into a folder with shape files, this is what you would see. For this one dense conifer shape file, these are all the files that are actually being used to create the one shape that I see. So they are vector data format. They can be points, lines, or polygons. But it's critical when you get a shape file that you have at least those top three files, the SHP, which is the geometry, the SHX, which is the index for the geometry, and the DBF, which is the attribute table or the DBase table. If you don't have those three, you cannot draw your shape file. It won't work. Now, the link I have is a ARC 10.3 discussion on shapefiles. The PRJ is the projection file, and it's not technically required because it's fairly easy to make a new PRJ file. The problem is I have to know what the projection was when the data was created. So when you create a shapefile, it will automatically have a projection. If somebody grabs the top three files and sends them to me without the projection file, I have to spend a lot of time hunting until I can find out what the projection was, create the projection file. Without that, it will not draw. It's pretty useless. So it's really important that you know the difference between a shapefile and a feature class, and what you need to be able to use a shapefile. So that brings me to the difference between a shapefile and a geodatabase. When I have a attribute table in a geodatabase, the shape and area file are automatically updated. And so if I were to cut Barview Wayside Park in half, I would have two new records, both of them called Barview Wayside, but it would give me the new area of each part of the park that I have cut in half and the new perimeter. The output of a shape file is not updated. So if Battle Mountain State Park, down in this lower image, were a shape file and I cut Battle Mountain State Park in half, it would not update the shape area. Now, generally, any of the other fields are not updated even in a geodatabase. So if I had a field saying average visitors per year, and now there are 2 bar waysides, and the average visitor was originally 50, both of these would show average visitors of 50. And so why should you care? Well, you should care because if you clip a shapefile polygon and there is a field like this one that says square miles or shape area, that will not update. So when I get my new clip feature here, it will still say that it is 100 square miles. So what tools do you have to your in your toolbox that would allow you to recalculate the correct area of the shape files once you have manipulated that feature or that shape? Right, you could use the calculate geometry, and so that's something you always want to make sure when you get a shape file. You don't know if anybody's calculated that geometry, and so that's something I would always just recalculate and double check. Okay. Stepped on my own slide. when you do a clip feature, the input again is the cookie dough, and again that can be point lines or polygons, and the clip feature is the shape, but the shape can only be a polygon, right? So if I have the input is park, so park is my clip feature. No, park is my input. So there's the cookie dough, and the clip feature is the geology. When I get the clip, I'm only going to have the attributes of the park. It will have I will have no geology information at all. If I wanted the geology information included with the park, I'd have to use one of the union or the intersect for that. So here is an example of all of the parks are in red hash marks, and the geology is this green layer on top. So the geology is kind of a solid layer, and the parks layer has got some spaces in it. And when I clip the area to the geology, so I really only want to be able to look at the geology that is in the park areas, and my geology feature class is smaller than my parks in general. So I could clip using my geology data. My output then is going to have only the park information, but it will have only the area of the geology, and you can see here the geology extended beyond the parks, but because the park didn't have anything there, it maintained that border function correctly. The intersect, however, is going to take both attribute tables and put them together, concatenate them into one record. So it looks like a clip because I'm using just the areas that overlap, but I'm going to end up with the attributes of both. So when I did an intersect, I got the rock type or the geology that is under Battle Mountain State Park and the geology that's under Emigrant Springs. And here's another section of Emigrant Springs that has a different geology, because remember, the integrate can split polygons. When you perform an intersect, one of your options or the parameters is how to set up that join. And the drop-down menu says, do you want to use the FID, no FID, or all? And so a bit of a review in ArcMap, an FID or an OID or an object ID are considered unique identifiers for that particular attribute table, and they're created every time you create a record within a table, but they are not usable as a key field because I may have an FID that starts at 1 for a geology type down to 500, and then I might have an FID that starts at 1 for land use type and goes to 50, but the 1 and the 1 are cannot be joined as key features because you have no way of knowing what their association is. So even though those numbers match, they are not considered unique identifiers for a join. The FID ArcMap documentation says that the FID and the OID are primarily used in shapefiles. The object ID is what you see more commonly in a GeoDatabase. And every time I join or manipulate, I can take an old FID and add it to my new data. So when I'm doing the join, if I choose all, I'm going to get the original FIDs for both feature classes and all the attributes. If I choose no FID, I'm going to get the attributes only, but no FID. However, there is a new object ID or FID that will be created, but I won't get the original FID from the geology or the original FID from, what did I say, zoning. If I choose only FID, all I get is the FID numbers, but no attributors. No attributes there. Okay, so just know when you're picking that, and it doesn't affect your join. Well, this one kind of does, because then you have no attributes if you need to kind of look at those attributes. Sometimes you just want the shape because you know what you've put in and you don't really care what the attributes are, but it can give you a lot of data. So again, the union adds the attributes and the spatial extent. So if I have a geology that has 849 records and parks with 300 and some records, I could potentially get massive amounts of records, not just where they add, but every time one polygon cuts another in half as it unions, then I could get tons and tons of records. The same with intersect. I can get lots of records, lots of polygons, and there's some ways to deal with that we'll talk about in a minute. One of the negative sides or the concerns with intersects and unions is that you can get these tiny infinitesimal polygons called slivers, and they can, over time, if you get enough slivers and you want to know perimeter of park areas, you could have all of these slivers that actually add quite a bit of inaccurate data to your map. So you really want to pay attention and kind of know what your sliver areas are. You can set your XY tolerance so that your when you integrate, it doesn't leave slivers. However, you could have such a big tolerance that you actually lose features or parks. So I don't know if that is up here. So if we could, can I zoom in? Maybe. No, shoot. Maybe. Let me see if I can zoom in on this. Yeah. So if you look here, you can see that there's some little tiny slivers right here, and there is not a separate park. So these are probably just areas that the tolerance of my map were not set large enough to take care of that. And so those are the kinds of things that you want to look for. Another geoprocessing option is the merge option. And so if you get a lot of polygons that you're trying to put two features together and they line up, and let's say you know that this is the field called zoning type and it's park, so you could have it merge on zoning type park or zoning type river, and it will put them side by side together. Now the one that's more often used for kind of a similar function is the dissolve function. So if I had all of the counties in the US and there was a field in my attribute table that said the state name, but I didn't have the state feature class, I could dissolve each of these counties on the state name, which means everywhere there is a state name and the counties touch each other, it would spit out one large polygon. And you can see how that would make my file a lot smaller and maybe even make my analysis a little bit easier if I didn't have quite so many polygons to deal with. And you could also use a summarize function. So if each of these counties had a population value, I could end up with a state and a summarized population. Now, dissolve is also used to simplify polygons. So on the left, the green image shows a limestone layer and a tree cover layer that were intersected. So everywhere the two polygons overlapped each other, it created this combined feature class, but there's also all of these lines in between. And I really just want the whole area. So if I were trying to locate a polygon that had a suitable area for planting, I'm going to not see the full extent of these polygons where their geometry coincide or is included. So you can do a dissolve function that actually puts all of these adjacent polygons together into one polygon. So it really simplifies my data. There is a trick with dissolve. At the bottom of the dissolve dialog box, there is a checkbox that says create multi-part features, optional. If you leave that checked, when your dissolve finish, you get what's called a multi-part feature, which ArcMap shows this as just one polygon, and you get one record for all the polygons. But I really want to be able to see each of these polygons separately. And so if I had unchecked that, this is what I would have seen in my attribute table. It would have taken each of these polygons then and separated them out or exploded them, so that I can now find the area of each separate polygon and not as just a combined polygon. So she'll work through that dissolve and multipart with you. Another geoprocessing tool is a buffer, and a buffer is often kind of an intermediate process. So for example, in the snail habitat, you're going to make a buffer around roads, and then you're going to take that buffer and use that as a way to intersect with your snail habitat to find areas that need to be thinned. Anyway, so a buffer can be used to kind of identify this spatial or this physical area around a point, a line, or a polygon. And it too creates a new feature class. But one of the tricks, again, with the buffer is in the dialog box that asks you, do you want to dissolve or not dissolve? If I don't dissolve, each road section here, so this is one section of road, here's another section of road, there's a third section of road, here's a fourth section of road. Each section of road has its own buffer, including a buffer around the end of that feature class or of that road section. So if this was, I think this was a half-mile buffer. So there's a half-mile on either side of the road, plus a half-mile at the end of that section and a half-mile at the end of that section. So if I choose to not dissolve, if I choose to dissolve those, then those endpoints or end caps are removed. This would give me a very inaccurate area. If I wanted to know total area that needed to be mowed around a highway, I have just really added to my area calculations, which would make it really inaccurate. Geoprocessing can be accessed from many places. One is there's a geoprocessing toolbox which has clip and buffer and intersect and union and dissolve. I think Price is going to have you use the geoprocessing Dropbox. Those things are also in the geoprocessing toolbox, so she'll have you use that. Then we're going to use Model Builder. And you can also, there are lots of little Python scripts. Used to be Visual Basic, but I think then that's still some of the older scripts in ArcMap, yeah. But she's going to have you run just the Model Builder, which is actually run on Python. So here's an example of Model Builder. And one of the nice things is a lot of people really get the visual workflow of Model Builder. So the blue circles are my feature classes that I'm inputting. The yellow are my processing, select by attribute, intersect, those kinds of things. And then this is my output. So I have a study area and a soils, and I'm going to clip those, and my output is soil clip. And I'm going to add a new field. And so it's going to call it soil clip 2, and then I'm going to calculate the field, and then run it as soil clip 3. It's a very simple tool, but let's say this is a process that's done in every city park across the country by the Park Service, and they want it all done the same. I could send you this tool, and all you would have to do is to input your feature class for your study area and your soils, and everything else would be automated.